Hi, it's me again, Isabella, and now we're going to be going into our fourth session. And this session is titled Compounding, Day Supply, and Adjusting Refills. So if you remember our last session, we went over apothecary system and metric, as well as the conversion of Celsius to Fahrenheit or Fahrenheit to Celsius. But in this current session, we're going to cover calculations that you'll experience when you're compounding. So figuring out like how many capsules or how many tablets you should be using for one particular order. We'll also work with calculations that ask on how many days will this order last if it's such and such directions. And then we'll close up with adjusting refills. And this information you're generally going to see more in the community setting pharmacies. So let's begin with compounding calculations. And just to give some insight on what compounding is, this long word that you see, extemporaneous compounding, what that means is it's the on-demand preparation of a drug product. It's something that's prescribed that uniquely fits the needs of an individual patient. In some cases, it can be for children who might have troubles with swallowing tablets, so we need to create a suspension for them to take. Some cases, people have allergies. Maybe they're allergic to the dyes that are used in a particular formulation, so we would have to compound something specifically without that dye for that patient. Sometimes it's just the patient in general cannot swallow something, they cannot take it a certain route. So we might have to adjust or change the route by creating something uniquely for that patient. And lastly, this can be for cases in which a product is just not commercially available. Such is the case when we have different dermatological type ointments or creams that we're trying to get the right formula, maybe a little bit of this antibiotic, maybe a little bit of this steroid to help with this particular patient. So it can be very helpful if a particular item is not commercially available. So what are the compounding problems? Again, you can be calculating for how many capsules or how many tablets you're going to need to create a particular suspension or maybe to add to an ointment or so forth. But you have to know conversion factors. And although compounding can be with sterile products, the majority of these types of calculations are going to refer to compounding that's done in the community setting. So items that are not necessarily sterile. The topic of compounding is covered more in depth in Chapter 9 of the Pharmacy Technician book. Now let's look at a compounding practice problem. So in this example, we need to prepare 150 milliliters of metronidazole, 50 milligrams per ml suspension. And just for a side note, metronidazole is an antifungal. It is the generic for Flagyl, and it's not available in a suspension in this case. So we're going to use tablets to make a suspension. The 50 mgs / ml, just to get the correct interpretation of what that means, is for every 1 milliliter, there's 50 milligrams of that drug. So you don't see a 1 there, but anytime you see a unit of measurement and no number, it really means the number 1. So now that we have that down, the question is, how many tablets of metronidazole 250 milligrams are we going to need for this order? Well, the answer must be in tablets. So tablets is going to begin the top of our first fraction. Now, what's true about tablet in this problem? Well, for each tablet, there's 250 milligrams of drug. So that's our first fraction in the equation. 1 tab over 250 milligrams. So let's move on to the next slide. Because milligrams is on the bottom of the first fraction, we have to put milligrams on the top of the second fraction. Remember, this is going to help with cancellation. We want to ultimately be left in the unit of tablet. And what do we know about milligrams? Well, the concentration of the suspension that we're making is 50 milligrams for every 1 mLs. So there we have it, the second fraction in the equation, 50 mGs over 1 mLs. Now, you might be thinking, well, what's next? Well, again, because we have mLs on the bottom of the second fraction, it has to be the unit on the top of the last fraction, or the third fraction. And really, it's just over 1. So like I said earlier, you could either put the 1 beneath the 150, or you could just leave it as I did. So notice the units canceling out. The mg is going to cancel with the mg. The ml will cancel with the ml, and we'll be left in tablets. So you take 1, divide it by 250, then multiply it by 50, divide it by 1, then multiply by 150. You get 30 tablets. Some people, that's the way that I do it, the route I do it. I kind of go from top to bottom, then top to bottom. Some people just go all the way across, which is totally fine as well. In that case, you would do 1 multiplied by 50 multiplied by 150, then divided by 250, and divided by 1. And what I'm speaking, you can actually directly follow that on your calculator. Before we go into a video illustration of a compounding practice problem, I would like to just show you a shortcut for these types of problems, and that would be an alternate route that you might take to solve these problems, and that is finding out the total drug present. So I'll use the same example of the metronidazole. So we have to prepare 150 mLs of metronidazole, 50 milligrams per ml suspension. Again, how many tablets of metronidazole? 250 milligram tablets will we need. So by knowing the total amount of drug in the finished product, and we do that by taking the concentration times the quantity we're making, and if we take that and divide it by the strength of what is present in each tablet, that will also give you the correct answer, or the number of tablets that we'll use. So you can see that played out on this slide here with the, in yellow, it says shortcut. So I just wanted to share that before we go into a video illustration of another compounding practice problem. With compounding calculations, and these are going to be found in chapter 16 of your calculations book. So let's take a look at this problem. We need to prepare 75 mils of levothyroxine. Levothyroxine we know is a generic name for synthroid or levothyroid. It's used for hypothyroidism, so if you have a low acting thyroid. And we're making the suspension, it's 75 mils, the total volume we're making, and the concentration is 8 milligrams / 2 mils. So that means that for every 2 mLs, there's going to be 8 milligrams of drug. So they're asking us how many tablets of levothyroxine, 100 mics or mcgs per tab will we need. So we know that we're going to be using these 100 microgram tablets, and we're trying to make this concentration of 8 milligram per 2 mils, total of 75 mils. So if we zone in on the question, if we look at the unit we want to end in, it's actually tablets, because we're trying to figure out how many tablets. So that will start our equation. Remember, this is crucial that you can key in on the unit you want to end in, because that will start our equation here. So what do we know about tablets? Well, we know that for 1 tablet, we have 100 micrograms of drug. And I'm sure you remember that the unit on the bottom of the first fraction, it's always going to be that next unit on the top of our second fraction. So before you even begin to fill things in, just go ahead and write that unit. So now what do we have with microgram? We have nothing. So this is a flag that you must use an equivalency that you've committed to memory. And in this case, we're using micrograms and milligrams. So we know that for 1,000 micrograms, we have 1 milligram. Okay, so that's a conversion factor that we've memorized. Now, same thing on the second fraction. If you have milligrams on the bottom, we know that we have to have milligrams on the top of the next fraction. So now what do you think we can incorporate? We can look through our problem. I see this concentration, 8 milligrams for every 2 mLs. Okay? Now, if we have mLs here, I know that mLs will be the very next unit. And we're coming to a close here because I'm going to be making 75 mils total here. So now that we've incorporated everything that the problem presented, we know that our equation is done here. But notice that we have the tablets that we're using here. This is a conversion factor. Okay? The next one is the concentration of what we're making. And lastly, we have the total volume of what it is we're making. So typically, this is going to be how we start or how we run through all of our compounding problems, because we're ultimately finding out how many tablets are we going to need or how many capsules are we going to need. So we obviously start with the number of capsules, what's present in each capsule. And then we're going to, sometimes we'll use a conversion factor like we did here. And then the concentration. And then the last thing would obviously be the total volume that we're making. So this is kind of a good thing if you are trying to put some logic to this or reasoning to this. You can kind of see the pattern that we're following here, and it will help you with our compounding questions. So that when we do this, you have some method that you can use or you can depend on, that there is typically a method that you can rely on or count on when you're setting up any questions for compounding. So this is the final equation, and if you want, you can see these numbers play out, and when you punch this on your calculator, what you're going to see is this 1 times 1,000 times 8 times 75, and that's all over 100 times 1 times 2. Notice I'm just taking then all the numbers on the top and then all the numbers on the bottom, so that when you punch that out, you get this 600,000 all over 200. So at least you're down to 2 numbers. So 600,000 divided by 200 gives us 3,000. So I know this seems, out of the ordinary. It's probably rare that you're going to do a compounding problem and using 3,000 tablets, but this is just for purposes of running through calculations. So our answer here is 3,000 tablets. So remember, please rewind, go through this video again. I know there was a lot of information, and it's just to kind of help strengthen your ability with compounding calculations. Thank you. That's all I have. So that was compounding calculations. Now we're going to move forward to days supply. And days supply simply means we're going to calculate for how many days an order with a particular or specific sig and directions and quantity, how long will that last? So we'll be calculating how long it'll last, and we'll have to have been given how the patient is using or taking the medication, as well as the total quantity. We will have to know our sig codes, and this is so crucial because they will not just spell it out for us how long or how a patient is using or taking something. So they might just state, a patient is to take 1 capsule PO QID. And so if you don't know what QID is, then you really can't move forward. So you have to know the Cigna codes. You must also know conversion factors, because most of the time we're going to be going from milligrams to milliliters, or if we're using number of tablets, or even with insulin, I have noted the 1 ml holds or has 100 units of insulin. Drops are another important one. For 1 milliliter, you can get anywhere from 15 to 20 drops, because the majority of times, in fact, you'll never see an order that's written for so many milliliters, 0.05 milliliters. I'm just throwing a number out there. Milliliters to be instilled in each eye twice a day. You just don't see an order like that. You're going to see something that says so many drops twice a day, each day. So, and then lastly, with topical creams or ointments or something we're applying to the skin, usually the rule of thumb is 1 gram for 1 application. So those are the factors that we're going to want to use for moving forward and calculating these. Now, you might wonder, why is this important, or what is the significance to these types of problems? And really, this is probably the second most frequently type of calculations you'll see in the practice setting or in the real world. And it's really important because we have to ensure that we're filling orders accurately. We have to ensure that we are indeed giving them a certain day's supply, because it directly corresponds with third-party claims or any resolutions of third-party issues. We want to ensure that we're ordering the correct quantity and making sure that we have the right quantity for a medication at the right timing. So it really is tied to a number of different things that you will see on a regular basis. So let's take a look at an example. We are to calculate the day's supply. So how many days will this last? For an order of alprazolam, 0.25 milligrams, number 30, 1 TID. Well, for any of these types of questions, we first want to figure out how much is the patient using in 1 day. Because then you simply just take the total quantity prescribed and divide it by what they're using in the 1 day. So if you do it in a dimensional analysis way, it's just 1 day, because we're solving for days, over 3 tabs. 1 TID means that they're going to be taking 3 tablets in a day, and then times 30 tabs. So really it is taking that 30 tabs and dividing it by 3, which gives us 10 days. So again, I'll repeat that. Calculate what the patient is using in 1 day, and then take the total quantity prescribed and divide it by what you've calculated for each day's dosing. This is pretty simple example. Let's take a look at another type example with the video illustration. Hello, now we're going to go through an illustration for day supply. And these types of problems are found in Chapter 17 of your calculations book. So day supply, when you hear that, we're trying to calculate the number of days that a given order will last as long as they give you how it's being used and the total quantity that they're filling for. So this particular question, we're asked, how many days will an order last for Lantus? This is actually an insulin. 1 vial / 10 ml, inject 15 units TID. So one hint that I'm going to give you that you should definitely commit to memory, and this is useful with day supply questions pertaining to insulin. And this important fact is that there are 100 units of insulin per milliliter. Because the prescriber will not give you the number of milliliters a patient should inject. Rather, he or she will prescribe the number of units the patient will inject. So this is an important fact that you want to commit to memory, especially for problems like this. So let's start. How many days will an order last for Lantus if we're given 1 vial and the patient's using 15 units TID? So like all my other questions, I ask you, what are they asking us? And we're looking for number of days. So we will start our equation with day. Now what do we know about a day? Well, you kind of have to think through this, and it's tied to the dose in a day. You see this 15 units TID? Well, you have to know that TID is 3 times a day. So if they're using 15 3 times a day, that's a total of 45 units in 1 day. So back to our equation, 1 day the patient will be using 45 units. Okay? The next fraction, we know units are down here, so you can automatically take units up here. This is for purposes of canceling out. So what do we know about units? Well, we don't have anything per se within the question itself, but with the hint that I gave you, we're able to incorporate 100 units for 1 ml. And lastly, mLs are here. We know that that will be the next unit incorporated, and the patient is given 10 mLs. So when you punch this out, just 1 times 100 times 10 for the top, we get 1,000. And then on the bottom, we just have 45 times 1, which is just 45. So 1,000 divided by 45, we get 22.2. And because these units cancel, units and units cancel, ml and ml cancel, we're left in days. So this is an illustration for day supply. Again, rewind if needed, and you can do several other similar questions found in chapter 17 of your calculations book. Thank you. So that was day supply. Now let's take a look at something that can also be tied to day supply regarding quantity of an order filled. And this subject matter is adjusting refills for short fills. And I'll first talk about the amount of a prescribed medication. And it's really restricted by your laws first, and then by the prescriber, because the prescriber must adhere to the laws set forth for whatever medication they're prescribing. Then also, which many people fail to understand this, is that your insurance also dictate or can restrict a quantity or an amount that you're getting for a particular medication prescribed. So what is a short filled prescription? Well, there's a few different scenarios in which a patient would get a short fill prescription. And it's basically they're not getting the full amount that the doctor or the prescriber wrote for. And number one, it could be that the pharmacy just doesn't have enough of that prescribed medication. So they fill an order with a lesser quantity than that which was prescribed. In some cases, they will, if you ever, a pharmacy ever tells you that they owe you, typically you might get a 3 to a 7 day supply, and then at that point you would come in after, 3 days or what have you to receive the remaining portion. Or if a patient's insurance plan doesn't cover the amount that is prescribed. So maybe the prescriber writes for, let's say, 90 days, but your insurance limits you to only 30 days. And then the last scenario would be if a patient is requesting a lesser amount than that which was prescribed. So let's go on to the next slide. When we are adjusting refills for these short fills, what do we have to know? Of course, we have to know the prescribed quantity. So I would calculate the total amount that is prescribed for that particular fill, as well as the refills. And so when I say that, I mean if a prescription is written for 60 at a time with one refill, then the total quantity prescribed would be 120. 60 for the first time and 60 for the refill. You also have to know the prescribed directions of use, or the SIG codes. How is the patient using them? Because you will have to know how much are they using in a given day. And just remember the day supply information that was given to you previously for the drops, insulin, and topical applications. So adjusting refills. In this, if you're still trying to kind of grasp what this is, if you can just think that whatever a prescriber writes for, even though your insurance will not approve for that quantity, or you decide to get a lesser quantity, we cannot take away what you did not use at that point in time. What we'll do is we'll just add it to refills. So that's why it's adjusting refills, because let's say you get a 3-month supply written at one time with no refills, but your insurance only covers 1 month. So 9 times out of 10, I would say the patient will get what the insurance will cover for. So that doesn't mean you lose the other 2 months. It just means that you're going to have 2 refills of 1 month supply each in that particular case. So hopefully that's helping you kind of grasp this concept of adjusting refills. So when we do the math for that, we will calculate for what the patient is going to get for that given day on that initial fill. Then we'll calculate for the new number of refills. And each fill will be the same quantity that we gave them on the initial fill. The quantity for the partial fill is just basically the quantity that's left over, that's less than what the initial quantity fill was. So hence, that's where we get a partial fill from. So let's go to the next slide and take a look at an example. We have an insurance plan that only covers 32 days. And the orders for naproxen, 500 milligrams, number 90, 1 BID, C, or which means with, food with 2 refills. So remember, step 1, what will the tab quantity be for the initial fill? Remember, how are they taking it? As well as what the insurance plan will cover. So if they're taking 2 tabs in 1 day, for 32 days, they're going to be taking 64. So now let's look at the total quantity prescribed. Well, it says number 90, but don't forget the 2 refills. So really, it's 270. 90 plus 90 plus 90. So 270. Well, if we subtract the 64 from the initial fill, or the first fill, we're left with 206 tablets. Now, if each fill has to be the 64 tablets, then we'll get at least 3 more full fills. And you can see, just take that 206 and divide it by 64. We get 3 point something. So we know that that 3 will be the whole refills, and the 0.219, when we times that by the 64, it actually is 14 tablets. So the answer for this will be 64 tablets is what is prescribed for the first fill. And because it leaves us with 206 tablets, we'll get 3 more full refills. And then the partial fill will be 14 tablets. So in your book, with the adjusting the refills, there's 3 lines that are asking you for what are you going to give on the initial fill, what are you going to give for refills, so that'll be whole numbers, and then what will the partial be if there's a partial. Some things you cannot give a partial for. For example, you cannot partial an insulin vial. You cannot partial boxes that come intact, or in some cases, you like nebulizer solution, or nasal sprays, or inhalers. Just think of unit doses that you could not break open and give only a partial to a patient. So why don't we watch a video illustration of an adjusting refills type problem, and that will conclude our section on compounding day supply, or we can sum it up with another part of community pharmacy, because this is typically compounding day supply and adjusting refills. So thanks, and be sure to rewind. That's the nice thing about these things. If you're not quite grasping something, rewind it, replay it, listen to it, run through it again, and contact us if you need further assistance. Thank you. Have a great day. Hi, it's Isabella here again, and I'm going to go through an illustration for a problem that deals with adjusting refills. And this is a type of problem that you'll probably just encounter on the certification exam. You might have to use it sometimes in practice if you are just trying to double check the computer's work. Typically, a computer system will run through what a patient will have on refills if there's a change in what the quantity is that's prescribed. So this is a type of problem that you'll see when a doctor or prescriber writes for something and the patient doesn't get the full quantity that was prescribed. It's not the case that they would actually lose that for every case. It just kind of adds to their future refills. So we're going to take a look at an example here, and it was pulled from your math book, chapter 18. We'll have similar type problems, and we are calculating these problems based upon a 34-day allowable refills. So the insurance is allowing us to fill for 34 days, so that's what we will base this on. So this is an example taken from page 135, number 11, amitriptyline, 25 milligrams, which is an older type antidepressant, and we have 100 tablets that are prescribed. The dosing is 1 HS, or 1 at bedtime, and there's 1 refill. So for these types of problem, first you want to calculate the total amount that's prescribed. So we see here that we have 100 tablets plus another 100 because we see this 1 refill. So the total number of tablets prescribed here is 200 tablets. Second, you want to tally for what's that first fill going to be for 34 days? N. We have to look at the dosing. We see here that it's just 1 HS, which means 1 at bedtime. So if they're just taking 1 a day and we're calculating for 34 days, that first fill will only be for 34 tablets. Okay, so what we end up doing is we're going to be taking 34 tablets from that original 200. So 200 minus the 34 leaves us with 166 tablets remaining on that prescription after the first fill. So the last question is, what are the number, or I should say the next question is, what are the number of refills that this patient can get if each fill is 34 tablets? So and what you could do is when you take 166 and you divide that by 34, you can see that they'll get at least another 4 fills. There's 4 refills. And if we have 34 for each fill, 34 times 4, you should get 136 tablets. So we'll also pull that from the 166 tablets. I'll just put this tabs from the refill. This was the first fill. So 166 minus 136. We still have some left over. You see, that's not entirely canceling out. We have 30 tablets remaining. Now, because each fill is 34 tablets, this 30 is actually considered a partial fill. So in your book, you'll notice that there's 3 empty slots. The first slot is for the first fill, which you would put 34. The second slot is for the number of refills, and we calculated it to be 4 here. The last slot is for the partial quantity, if there's a partial remaining. And in this case, we'll have 30 tablets as our partial. So this is an illustration for adjusting refills. And again, you may not see this too often in real life, but it is very helpful to know how to run through these in case you wanted to double check the computer's work. So thank you for your time.